All right, good morning, everyone. Today we're doing lesson 4.4, dividing polynomials. As you can see, I already labeled some of this for you guys. I just want you to understand that the dividend is what you're dividing, divisor is what you're dividing by, and the quotient is your result, how many times it can go into the dividend. An example is if you divide 10 by 3, it goes in 3 times, so that is your quotient, and your remainder is 1. The remainder theorem says P of k is equal to the polynomial divided by your factor. The factor theorem says if P of k is 0, then x minus k is the factor of your polynomial. Number 1, it says 9m cubed minus 24m squared divided by 3m, and this is going to give you this. How did I get that? Well, 3m times 3m squared would give me 9m cubed. And that's if you subtract, right? Because you're going to subtract, that's going to give me 0. Then you're going to bring this down, and that's going to be negative 24m squared. And you think 3m times what gives me negative 24? 3 times negative 8 will give me negative 24, and m times m will give me m squared. So there I have it. I subtract, right? If I subtract this, then this is going to be positive. If you distribute the negative, 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 positive. So this cancels, and your remainder is 0. All right, number 2. Number 2 says, use factoring to divide the polynomials below. We have 4h squared minus 7h minus 2 divided by h minus 2. Now you think, how am I going to get this from this? I know that I'm going to need a 4 and another h. 4h times h is going to give me 4h squared. And then we're going to do 4h, right? 4h times negative 2 is going to give me negative 8h. Subtracting will flip each sign. This was positive, now it's negative. This was negative, now it's positive. These cancel. 8 minus 7 is just 1. I'm left with 1h. And I bring down the negative 2. Now I have to think. H times what will give me negative 7h? Well, h times negative 7, right? Negative 7h is what I have. I messed up here. Sorry. Negative 7 times, disregard what I said. We have to make it equal to h. Sorry, guys. So we have plus 1. 1 times h is just h. And then 1 times negative 2 will give me negative 2. And if I multiply by a negative, right, if I subtract this, what's going to happen? This positive h is going to be negative, and this negative 2 is going to be positive. There, I distributed. H's cancel, 2's even cancel, and we're left with the remainder of 0. So, by the remainder theorem, by the factor theorem, if P of k is 0, then this is a factor. Okay? So this is a factor here. This would be P of k, and it's 0. So therefore, this is a factor of the polynomial. Number 3. Number 3 says divide. We have x squared minus 16x plus 63 divided by x minus 9. Same thing. X times x will give me x squared. X times negative 9 gives me negative 9x. Subtracting flips the signs. These cross out. I'm left with negative 7x. I bring down the 63. Now, negative 7 times x will give me negative 7x. I'm just trying to copy them, right? And then there's a second term here. So negative 7 times negative 9 is positive 63. And look at that. If I multiply by a negative, this is now positive. And this is now negative. Remainder 0. So this is a factor. Number 4. Divide the polynomials using long division is the same way. Honestly, you guys know how to do it that way. I'm going to teach you a new way by factoring. This is the difference of squares. Okay, I'm giving you permission to use a different method just because I feel like this method is more quicker and advanced. It requires you to know this step. Okay. Difference of squares, you write it like this, right? Basically, it's a squared minus b squared is a plus b times a minus b, where in this case a was x and b was 6. Our answer is x plus 6. Which is a factor because remainder is 0. Number 5. Remainder 0 means there's no leftover. Divide the polynomials using long division again. You know how to do that. Number 6. Six again. 7. Okay. Yeah, it's the same thing. Now, I want to go over number 7 just because how they wrote it. So when you have x squared minus 7 divided by x plus 3, I know that x times x will give me x squared. Good, I copied it. And then x times 3 will give me 3x. And if I subtract, this will be a negative, right? This will become a negative, and this will become a negative. Right? And so we're left with negative 10. Ooh, very interesting. You see how we can't subtract these? So you're just going to write them the same. You're going to write negative 3x minus 7. And then you're going to move on to the next one. You're going to say, well, what's x times negative 3 is negative 3x. And negative 3 times 3 is negative 9. Negative 9. And so multiplying by a negative will change this to a positive and a positive. These cancel, and I'm left with a remainder of 2. How they write it, though, is x minus 3 is the quotient with a remainder of 2. And remember, what are we dividing by? X plus 3. This is the answer. Right? And that 2 was positive, so that is a plus that. Number 8. Number 8 is very similar. Okay, now we're talking. Synthetic division. We're going to have x squared now, in front of this is a 1. This is an 11. This is a 15. We grab each of those, and we're going to divide it by x minus 3. What number is, we're going to divide by x, right? X when it is a certain number. Remember, we're looking for the factor, so this has to be equal to 0, right? So therefore, if this is a factor, right, what is the x? The x, right, by the ZPP, you would set it up like this. If it was 0, then it would check out. So therefore, x is negative 3. You're going to put that here. So if this was positive, you're going to put a negative 3 here because that's what x is. Negative 3 is x. Plus 3 will give you 0. Bring down the 1. 1 times negative 3 is negative 3. 11 plus negative 3 is 8. 8 times negative 3 is negative 24. Plus 15 is going to be 11. Negative 11. Okay, but how do you make the quotient? Well, since it started off with the squared, this is going to be x to the first. It's just 1 less. That is a positive 8 and a negative 11. Remember, this is the remainder, right? Oh my gosh, I got my addition wrong. Sorry. Negative 9. From 15 to 24 is 9. Just goofed up right there. Anyways, your answer will be x plus 8 minus 9 over what you're dividing by. What are you dividing by? X plus 3. All right, that is the answer. Number 10. Number 10 says find the remainder when, you have 8k cubed minus 66k plus 14k plus 8 and is divided by k minus 8. Again, we're going to flip that sign because you know that k is 8 because 8 minus 8 will give you 0. And again, we're trying to make this equal to 0 to find out what k is, right? Dividing by that factor, dividing by this, in which k is 8. And we're going to see if this will equal 0. And we'll see. So, for the k cubed, we have 8. Oh my gosh. We have a k squared here? Yeah, that's a k squared. Negative 66. We have a 14 and an 8. Dividing by 8. Bring this down, right? Bring down the 8. We got 8 times 8, 64, minus 66, negative 2, negative 16, negative 2, negative 16, negative 8. That's your remainder. We got x. It was third. It's squared here. This is x. And then no x. Yep. And divide that by whatever you were dividing by. So that would be k minus 8. So this is your answer. Oh, and it says find the remainder. So they're only concerned with negative 8. That was your remainder. All right. Looks like we have 11 through 13 left. Number 11 says use the remainder theorem to find the remainder when 2x cubed is divided by this. Similar, right? You guys can practice on that. Number 12 says the polynomial p is graphed below. What is the remainder when p of x is divided by x minus 3? Okay, so if it's graphed below and is divided by x minus 3, that is when x is 3. Okay, so for this one, you have to know that if p of x is divided by x minus 3, you got to know that that's going to equal your p of 3. And the polynomial at x equals 3, right? At x equals 3, because that's what it is equal to 1. If you look at the graph. So look at the graph. That polynomial at x equals 3 has a value of 1. This is the polynomial's graph. What is the remainder when p of x is divided by x minus 3? The remainder was 1. Because p of 3 was 1. Right. Number 13. And that goes back to whatever theorem that we were analyzing. That was the remainder theorem. 13. X equals 3 is a 0. Find other zeros algebraically. Well, basically you have x cubed I know it's divided by x plus 3 because your x is, minus 3. Because your x is 3. Well, anyways, they tell you that your x is 3. So that's what you're going to divide by. My cubed is 1. negative 2 for the squared, negative 5 for the x, and then the 6. Bring down the 1. 1 times 3 is 3. 3 minus 2 is 1. Times 3 is 3. Minus 5 is negative 2. Times 3 is negative 6. And they were right. It is a 0 because the remainder is 0. So therefore, this is a factor. My new function, instead of x cubed, is going to have x squared. That's a positive 1x minus 2. This is the rest of it. So I know I can rewrite my polynomial, right? I know this is a 0 already. I need to find the zeros here. Because this polynomial is equal to x squared plus x minus 2 times x minus 3. And we set that equal to 0 and solve for x. And how do we do that? We factor it. If we have this function up here, we do our x. 1 times negative 2 is negative 2. Our b value is 1. And we have 2 times 1 is 2. And I want it to be positive. This is, okay, so 2 times negative 1 is negative 2. And then 2 minus 1 is 1. We have x plus 2 and x minus 1 as factors for this part. But don't forget the x minus 3. Now that is equal to your entire p of x. P of x. It's a p. So now you know that setting this equal to 0 to find out what x is, my zeros are, that's how you find zeros. You set the p of x, which is your y, equal to 0. Set y to equal to 0 to find your x, which is your zeros. The same thing, find x. When? Find your x-intercept when you set y to 0. So again, if this was 0, then 0 times anything would give me 0, and that would check out. So let's do that. X minus 3 is 0, so x is 3. Okay, well, if this was 0, that'd be great. X minus 2, x plus 2, if that was 0, that'd be great. There we go. And if this was 0, that'd be great. 3, negative 2, and you do it from least to greatest. Negative 2, 1, and 3. And those are your answers. Remember, least to greatest. All right, great job, you guys. We're done, and I'll see you in the next one.